Can 5 sine angles and a square really give you a single number? Let us find out what JEE Mains 2022 threw at us. If sine square 10 into sine 20 into sine 40 into sine 50 into sine 70 is equal to alpha minus 1 by 16 into sine 10 degrees, we are supposed to find the value of 16 plus alpha inverse. This is a numerical value type question from JEE Mains 2022. Let us break it down. Let us consider the left hand side of the given expression. Here we can write sine square 10 as sine 10 into sine 10 and other terms are rearranged. Here we have sine 70, next sine 50 is here and sine 40 and sine 20. Now we will consider sine 70 into sine 50 and sine 40 into sine 20. We can use the identity sin A sin B is equal to 1 by 2 into cos of A minus B minus cos of A plus B. Here A is equal to 70 degrees and B is equal to 50 degrees. Upon using the identity, sin 70 into sin 50 becomes 1 by 2 into cos of 70 minus 50 minus cos of 70 plus 50. Cos of 70 minus 50 is nothing but cos 20 and cos of 70 plus 50 is cos 120, which is minus 1 by 2. We have minus in the formula, so minus of minus 1 by 2 is plus 1 by 2. From the formula we have 1 by 2 here. Sin 10 is carried to next stage. Similarly, when we apply the identity for sin 40 into sin 20, that becomes 1 by 2 into cos of 40 minus 20 minus cos of 40 plus 20. Here A is 40 and B is 20. So cos of 40 minus 20 is cos 20 and cos of 40 plus 20 is cos 60, which is 1 by 2. Now let us multiply each term by sin 10. That is, we have 1 by 2 as it is, sin 10 into cos 20 plus 1 by 2 into sin 10 in the first term of the product. In the second term, let us keep 1 by 2 as it is and let us multiply again by sin 10. So we get sin 10 into cos 20 minus 1 by 2 into sin 10. Now let us use the identity sin A cos B is equal to 1 by 2 into sin of A plus B plus sin of A minus B. You can compare here. A is equal to 10 degrees and B is equal to 20 degrees. In the second term also we have sin 10 into cos 20. The same formula is applicable here also. Therefore, sin 10 into cos 20 becomes 1 by 2 into sin of 10 plus 20 plus sin of 10 minus 20. Sin of 10 plus 20 is sin 30 and sin of 10 minus 20 is sin of minus 10, which becomes minus sin 10. So we have 1 by 2 into sin 10 cos 20 becomes 1 by 2 sin 30 minus sin 10 plus 1 by 2 into sin 10 as it is. Similarly, in the second term, 1 by 2 is here as it is and sin 10 into cos 20 is replaced by 1 by 2 into sin 30 minus sin 10 and minus 1 by 2 sin 10 is carried to next stage as it is. Now let us simplify this by taking 1 by 2 common. When you take 1 by 2 common in the first term of the product, we have 1 by 4 outside and sin 30 as it is here minus sin 10 plus sin 10 in the first term of the product. And we have 1 by 2 into 1 by 2, that is we are taking 1 by 2 outside the bracket in the second term of the product. So we have 1 by 2 into 1 by 2 here and sin 30 minus sin 10 minus sin 10 again. So we will simplify term by term. We have 1 by 16 into 1 by 2, that is 1 by 4 into 1 by 2 into 1 by 2. we have 1 by 16 here, and sin 30 is 1 by 2, minus sin 10 plus sin 10 is eliminated. And in the second term, we have sin 30 is 1 by 2 here, minus sin 10 is nothing but minus of 2 sin 10 degrees. When you multiply by 1 by 32, that is 1 by 16 into 1 by 2 is 1 by 32, multiply by 1 by 32, that is we are removing the bracket. So we get 1 by 64 minus 1 by 16 into sin 10 degrees. Let us recall the given identity, that is it is given that if sin square 10 into sin 20 into sin 40 into sin 50 into sin 70 is equal to alpha minus 1 by 16 into sin 10, we are supposed to find the value of 16 minus alpha inverse. Now you can compare this. We have alpha is equal to 1 by 64. Therefore, 16 plus alpha inverse, this is the required value, which is equal to 16 plus alpha inverse is 1 by alpha, which is 64. So 64 plus 16 is 80. So the required numerical value is 80. That is how we can solve tough JEE main questions easily. Remember, applying the right identity is the real trick. If you like this video, please share with your friends and subscribe to Srividya CET JEE PUC Maths channel. Comment below if you want more problems like this. Thank you.